Hello Year 8, this is a quick video just in case you are having difficulty reaching the textbook. So it's a brief introduction to types of chemical reaction. We did have a chance to touch upon this in our last lesson before we had to start the distance learning. So just a very quick reminder, I'm going to take you through some of these points as well, just to make sure that everything is clear. So it does look like as if it's a lot of information, but don't be put off. It's very, very easy to classify all of the different chemical reactions that you get into these following categories. And like the introduction says, understanding these changes is really, really vital to the work that we do as chemists. It also helps us to try and predict what reactions will make, which is the reason why I always refer to general word equations when we are covering a topic. So like say, for example, we have been studying very recently how acids react with metals. So I can use that so long as the metal is fairly reactive and the metal is higher than hydrogen in the reactivity series. I can actually use that to predict what the products are whenever I add an acid, any acid, to a reasonably reactive metal. So I do that because I can understand that that type of chemical reaction is what we call as a displacement reaction. So you can use that knowledge to help you predict all sorts of different chemistry. And by learning all of these 4 different categories of reactions, you should be able to become a brilliant chemist yourself. So I'm going to go through combustion first. Now, combustion, we've seen this hazard symbol several times when we're doing experiments. This symbol tells us that the material can burn very, very easily in air. Flammable is the key term that's used for that. But also you can find the word inflammable, and they actually mean the same thing. So the meaning of the word combustion is a reaction where a substance will react with oxygen. Normally that oxygen is provided from the air. And a brilliant example for this, and a very everyday example of this, is a Bunsen burner. So a Bunsen burner will use methane as that fuel. The methane in that fuel will react with oxygen in the air. And one of the activities that I've given to you in an earlier task 2, what is combustion, actually takes you through that chemistry. So carbon dioxide and water vapour are produced as a result of it, and we can use this experiment to collect and test for those products of fuel combustion. So this experiment is actually a really important experiment because it actually proves to us that combustion will form these 2 chemicals, carbon dioxide and water. Now for the extension students are going to be studying another type of combustion called incomplete combustion. And that incomplete combustion comes about because not enough oxygen can be provided to combine with everything that there is in a fuel. So this is an experiment that can be used, and it involves a suction pump, and basically what happens is this. You burn a fuel, and this can actually be a liquid fuel. It's often the fuel type that we prefer because it's easy to control and it doesn't release too much heat. So you can burn a fuel and the fuel soaks up through the wick, and you can light the end of the wick and the end of the wick burns the fuel. Now those gases would escape everywhere, so what we need a way in which to collect the gases and allow them to pass through a system of tests that could confirm that these gases are indeed what we think they are. So this over here is indicating that there's a suction pump. In reality, the situation is what we would connect here is we would connect a 3-way pipe, and we would actually have a tap running constantly here. So water would be constantly running here, and what actually happens is the air pressure here decreases because this water is gushing through and it's actually taking along air downwards. This would be happening near a sink. So as the air pressure decreases here, air is actually taken all the way through the system to replace that air. So you can imagine it to be the scientific equivalent of getting a straw and sucking out the air constantly. Now we can't obviously do that as scientists because that would be relatively unsafe. So what we use is tap water just to gush it through. And you imagine it like as if you're standing next to a waterfall and you can feel the waterfall rushing the air past you. So this is exactly how a suction pump works. Now we have two different parts to the apparatus here. Now, number one is cold water with ice. If we focus just over here, with ice here, so it actually provides a very cold surface for this piece of apparatus. Now, believe it or not, this piece of apparatus is called YouTube. So the irony of this is that you're watching YouTube and I'm teaching you about a YouTube, which I think is relatively funny. So any gases that are coming through here, any of these hot gases that are passing through here, that are being sucked through the suction pump, can hit the surface of this YouTube on the inside layer. Now, that's going to be very, very cold. So what actually happens is this. One of the products is water, and water comes out from here at a very high temperature, hotter than 100 degrees centigrade. That water vapor passes through here, and as soon as that water vapor hits the cold surface, the water vapor will cool down, and the temperature of the water vapor decreases below 100 degrees centigrade. As soon as that happens, the water vapor will turn into liquid water. So what we will find over here is we will find liquid droplets starting to form. Now, when we do this experiment, we'll find that it's colourless liquid droplets. And a great thing about one of the lessons that we've done very recently is that we have done tests for gases. Now, can you remember what the test for water is? I hope you can remember that there are two substances that we can use to test for water. One is anhydrous copper sulfate, which is white in colour but will turn blue in the presence of water. The other is anhydrous cobalt chloride. Anhydrous cobalt chloride starts off as a very light blue, but in the presence of water, it turns pink. So what we can do is we can collect this colourless liquid and we can dip it into a sample of anhydrous cobalt 2 chloride or anhydrous copper 2 sulfate. And if we get those colour changes that we studied a few lessons ago, we will be able to confirm that that colourless liquid is 100% water. It doesn't confirm to us, however, that it is pure water. What we would have to do is we would have to do a further test. We would actually have to have enough of that liquid to measure the boiling point. If we measure the boiling point and it's perfectly 100 degrees centigrade, then we know that it is pure water. So that is the first gas that comes through. The first gas that comes through is water. And the second gas is related as well to one of the tests for gases that we have recently done. So you'll notice that I have said over here that carbon dioxide is the second gas. So the chemical test for carbon dioxide is a chemical test that you studied way back in week 1. remember the foldable leaflet that you did? Now would be a good time to pause the video and go get that foldable leaflet, the one that told us all about testing for gases. Right, you should have your leaflet in front of you, and that leaflet tells you about the test for carbon dioxide gas. So if we were to have some carbon dioxide bubble through, and remember it is bubbling through because the gases are being sucked through the apparatus by the suction pump. If we were to bubble it through colourless lime water, it will turn a white, milky, cloudy colour. That is the confirmatory test for carbon dioxide. It turns from colourless to white, and that confirms that carbon dioxide is the second product. Here's a quick reminder of the tests for water that should be on your leaflet. And now I hope you realise why it is that I asked you to do that leaflet. The reason why is because it links to the material that we're covering today. The second class of chemical reactions is thermal decomposition. Thermal decomposition basically means if you heat a substance, it breaks down into more substances, more simpler substances. Copper carbonate is a great example. Copper carbonate will break up to form two substances, carbon dioxide and copper oxide. And again, what you can do is you could test the carbon dioxide that comes from here. You could have a bung with a glass delivery tube connected, and that delivery tube would be connected through an L-shaped delivery tube into an empty test tube, but you need to have that empty test tube filled with colourless lime water. If you do get that, then you'll get exactly the same result as you have here. So again, the product of this reaction could be tested using lime water, and you'll notice that there is only one chemical written on the left. We never put heat in chemical reactions. You have to be very careful with that. Sometimes online you will see heat or heat energy in an equation. It is wrong. We need to make sure that you understand, as a chemist, we never ever put heat as a reactant or as a product. So heat is not a chemical and does not get included in the reaction. The third type of different reactions that you need to study are oxidation and reduction reactions. Oxidation occurs when a substance reacts with oxygen. Now, we've studied combustion. It's a great example, but there are several others. And we have been studying metals reacting with oxygen. So remember the copper square that I nailed on the wall of the lab? The copper oxide that formed as a result as a product of oxidation. Here we have an example of zinc, which is another metal reacting with oxygen. Have a look at the balanced chemical equations. You know I love balanced chemical equations. I really want you to do very well with them, and that's why we had so many balanced chemical equations to practice with. So here we have two oxygen atoms in an oxygen molecule. Zinc, we have zinc here, and we have two zinc atoms. The formula for zinc oxide is ZNO, and this is a balanced chemical equation. A long time ago we had a test, and we had the blast furnace. This is a very complicated set of results. But this is in the blast furnace, this is probably the most important overall equation that you could cover. The blast furnace is a chemical process where you extract iron, which is so important in industry and for our everyday lives. And we use carbon in the form of coke, which is a refined fossil fuel, so it's a refined version of coal, and that carbon can take the oxygen away from iron oxide. leaving the iron. The carbon will eventually turn into carbon dioxide. It's an interesting process. At GCSE, you'll learn a little bit more about this, and you'll actually find that the carbon first turns into carbon monoxide through incomplete combustion, and then what happens is the carbon monoxide prefers to take away the oxygen in a better way than the normal carbon does. But that's for GCSE. So at this moment in time, you've got to realise that this is losing oxygen, this is gaining oxygen, and the way that we classify oxidation and reduction is we say that when something is losing oxygen, it is being reduced. If something is gaining oxygen, it is being oxidised. So the final reaction, I've touched upon it already, is displacement reaction. And displacement reactions is something that we covered when we were doing the reactivity series of metals. So just a quick reminder, in a displacement reaction, a more reactive element takes the place of a less reactive element in a compound. This can be used to test the reactivity series of the metals, and we covered this for several weeks earlier this year. Now, in GCSE, you can also go on to talking about how non-metals, such as the group 7 elements, can also be shown to form a reactivity series. But for now, I want you to make sure that you understand that displacement reactions are something that you can use to classify a type of reaction. A little bit of a clue, a little bit of a peek ahead as to how you can use the ideas of displacement reactions to classify the reactivity series for non-metals in group 7 here. Okay? Right. So, I hope that by the end of this video you are able to come up with answers to these types of questions. Now have a look at these questions, pause the video, come up with some answers, and I'll take you through how you should have done those answers. So the first reaction over here, it says, what type of reaction is this? Well, this is clearly oxygen joining onto something. This is an oxidation reaction. Describe the test of 2 chemical tests for water. I hope that you came up with answers that involved anhydrous copper sulfate and anhydrous cobalt chloride. Remember to say what they were before in terms of colour. So the anhydrous copper sulfate was white, it turns blue. The anhydrous cobalt chloride, which you can state as cobalt chloride paper, starts from blue and it goes to pink. Thermal decomposition is a reaction in which only one type of chemical is written on the left. And the reason why is because the heat causes that chemical substance to break down, and that is called decomposition. Explain what you would expect to see if copper was placed into magnesium sulfate. Well, you wouldn't expect to see anything because magnesium is higher in the reactivity series than copper, so no reaction would take place. And displacement reactions can also be oxidation and reduction. Use examples of reactions to show this. So a displacement reaction over here, coming back to the blast furnace, you can actually see that the carbon is oxidized to form carbon dioxide, but the reason why is because carbon is higher in the reactivity series than iron. So I hope that takes you through everything. Thank you very much for watching. It doesn't take too long, but leave a subscription, like this video, and if you have any comments, please leave a comment. Stay safe, stay at home, and I look forward to seeing your quiz results. Bye, Year 8.